G'day everyone, we're back here with another integration video. This one is one that you need to be able to see, okay? If this came up in an exam and you hadn't seen this sort of thing before, you wouldn't know where to go. And sometimes they will tell you to use a substitution and what it should be. Other times it'll just say integrate the following or evaluate the following. And if you haven't seen this one, you'll have no idea where to go. This actually works out really simple when you know what to do. So what I've done here is I've chosen a substitution. And you might say, why? Where did you, how am I going to figure that out? Well, what I've spotted here is there's 16, which is 4 squared, minus x squared. Now, if you remember your trig identities, you've got sine squared plus cos squared equals 1. Now, I can multiply everything by, let's say, 4, that'll be neat, and get 4 sine squared theta plus 4 cos squared theta equals 4. So I can make any multiplication that I want across that equation. Now, this substitution here, when I make this substitution into there, you can see I end up with this part on the bottom. Now then I've got 16 minus 4 squared, 16 sine squared theta. And what that allows me to do is all of this here becomes 16 cos theta. That's all this. All this breaks down to 16 cos theta. Square root of that will get me 4 cos. All right? Think about that. I'll put that one in there. I square both parts. Here we go. Let's do this. I square everything. That then fits in there, the squared version of it, which is really 16 sine squared theta. So that whole thing in the green circle there just comes out as 16 cos theta. Oh, sorry, cos squared theta. And then I could write that as 4 cos theta squared. And if I'm squaring that and then taking the square root of it, well, that just cancels that part out. I'm down to 4 cos theta all here. This whole thing is just 4 cos theta. So let's get that in over here. 4 cos theta. That's all we've got left on the bottom line. Now remember, this is in terms of x, but I've made a substitution. It's now in terms of theta. So I've got to tidy that up. So let's come back here without the squares, the original substitution. Let's differentiate this. Won't we get dx d theta? Sine differentiates to cos. Leave the 4 there. We don't do anything with that 4. Won't that just become 4 cos theta? And then what I do here is I say, well, I'm going to divide that by d theta. Remember, it's not really a divide. They're not fractions, but we often write them as fractions. So if I multiply top and bottom line by d theta, then isn't that just that? So over here, wouldn't I have to put in times 4 cos theta d theta? And hopefully you can see, isn't that just going to cancel? Well, of course it is. That's going to cancel with that. I would have really had a 1 left on the top line here, from way back over here. So isn't this really now just the integral of 1 d theta? That's all I've got left. But I'm not done yet, because way back over here I had some limits. So if I've got limits, they're in terms of x. I'm now all in terms of theta. So I've got to change those limits. Here I've done it. Look, x equals 0. That's from here, lower limit. I take that x equals 0 and I put it in here for x. So I've got 0 equals 4 sine theta. Divide both sides by 4. 0 equals sine theta. Therefore. Similarly here, x equals 2. Put a 2 in there. Divide the 4 across. That's 2 over 4 a half. Therefore, sine to the minus 1 of a half, pi over 6. So my limits, now let's add them into both of these ones. Pi over 6 and 0. Pi over 6 and 0. Now I've just got to do the integration here with respect to theta. So integrating 1 with respect to theta is just theta. That's all. Integrate 1 with respect to x, it's just x. So this is really just going to be theta between 0 and pi on 6. Put those limits in, pi on 6 goes in, minus 0 going in. The answer is just going to be pi on 6. Done? I mean, back over here, you would never have spotted that. If you haven't seen this sort of question, you'd never look at that and go, oh, that's going to be pi on 6. But once you've done the substitution, tidied up, multiplied by what you need to get it in terms of theta, changed your limits, it actually falls out real neat. This is simple. So my tip here is make sure you can do integrations using a trig substitution. In an exam, you could do this, play around with it for 10, 15 minutes, and you'll literally get 0 marks because you won't have spotted or done any of the skills. The skill is recognizing the substitution and using it. Changing your limits, changing this, doing the integration, getting an answer, substitute. It's a 4 or 5 mark question. And if you know what you're doing, as little as 30 seconds or a minute. So you pick up 3 minutes. If you don't know what you're doing, 10 minutes and you might get 1 mark if you're lucky somewhere. So please know how to do these sorts of questions. Integration using a trig substitution, very important you know what you're doing. Hope this video has helped. Catch you later.